Hi mobile developers, in this video I'm going to show you how using the decorator pattern along with a generic decoratee can scale the login across your entire application. I'm gonna leave the link of the video where we assemble this architecture in the description. And for today I want to scale by logging when we get an error when trying to retrieve the position of the International Space Station. There's two places that I can see where we could log the errors, either in our EventsLoggerDecorator that decorates the AlmoFire HTTP client, by creating a custom completion handler and injecting it to our decoratee and logging the error localized description, and then invoke the completion handler with the result. But in this case, this is not what I want to do. Instead of logging events in the HTTP client level, I want to be logging connectivity errors on the application level. So we're going to decorate an abstraction of type ISSTracker position loader. So we are going to make our remote ISSTracker position loader to conform to ISSTracker position loader, and our EventsLoggerDecorator will hold an instance of the same type. The ISSTracker position loader has a method called loadISSPosition and completes with a completion handler of type queryResult. So our strategy, same as with the HTTP client, is going to be to extend our EventsLoggerDecorator to implement the ISSTracker position loader abstraction. Alright, so let's go ahead and implement our EventsLoggerDecorator extension. For that, we're going to start with a test as always. So before I jump into the first test, I want to identify the behavior that we're going to be testing. We need to log the error when the position loading fails, and we do not want to log any events when the position is loaded successfully. So test logs connectivity error on position loading failure and does not log event on position loaded successfully. Let's begin with our first test. Again, the given when then section. And we're going to start by implementing our factory method, which is going to return an object of type ISSTracker position loader. We want to import our module, and in here we want to instantiate our events logger decorator. We're going to inject a dummy logger and the onlogging called closure as an argument. And for the decoratee, we're going to implement in this case a stub that is going to receive a result of type ISSTracker position loader result. So here we have our stub, and we're going to make it complete with a stubbed result. So in our factory method, we're going to instantiate it and inject it to our logger decorator. And our stub, same as with the onlogging called closure, we're going to inject it as an argument to our factory method. Let's implement the arguments injection. To assert that the log event was called, we can create a variable log error call count, and in our closure we can increment it in 1. For our stub results, since we want to test that the error is logged when the position failed to load, we're going to inject an error of type connectivity. In our one section, we want to invoke our abstractions method, and also here is where we're going to put our assertion. So we're going to assert that the logger error call count is 1, and we're going to create our expectation. We're going to fulfill our expectation inside the closure, and then in our then section we're going to wait for the expectation's fulfillment with a timeout. That's our test implemented, and now the compiler is complaining that the EventsLoggerDecorator does not implement the ISSTracker position loader protocol or abstraction. So we're going to go ahead and implement it. Also, we want to conform the decoratee to the abstraction. Now we implement the abstractions method, and we can run the test to see a failing test first. And there we have our failing test, which failed because the expectation was not fulfilled. So now, following TDD, we want to make our test pass. So we're going to invoke log event with some error. So now we want to forward the message to the decoratee and inject it with a completion handler. Run the test again. and it passes. Now we can move to our second test, and since it's gonna be quite similar to the one that we just implemented, we can copy paste the previous implementation and we can start changing it to do what we want. So our expectation is waiting for the position loading to succeed. Secondly, the start result is going to be a success, and we're going to inject any position. And our assertion is going to check that there was no logs invoked. So the login call count should be 0, and we can run the test. And it fails because we are not differentiating between the error and the success case yet. So the strategy is going to be to inject a custom completion handler to the decoratee, and we're going to switch over the result. So when there is an error, we can log the error's localized description, and in the success case, we just want to break and get out of the switch. And finally, we want to call the completion handler to forward it to the decoratee. We're going to run the tests again, and now we can see both tests passing. So as Mike would say, let's commit. Conformance of EventsLoggerDecorator to ISSTracker position loader abstraction with its tests. Now it's time for some refactors. As you can see, these tests are very similar. So we could implement a helper method that will help us understand the tests better and reduce the code duplication. We're going to pass as arguments the login call count expected and the stop result, and we're going to move all the tests logic into this helper method. There we have it, and now we can modify our tests to invoke this helper method. So expect 0 login events called count for a given position. And similarly, we can refactor the first test, but here we want to expect 1 login call count when the start result is an error of type connectivity. Run the tests, and they're still passing. Let's commit. Creating helper methods to improve code tests quality and avoid duplication. So I'm pretty happy with this refactor we made, because we are checking that the login count is the correct one, and also thanks to the expectation, we are achieving that the closure, when we invoke the load ISS position method, is invoked only once. If by any mistake we would complete twice, now if we call the tests, we will have a failing test, and it will indicate that the expectation was called more than once. So we are safe in that area, but there is something we can improve in our tests. We are only checking that the invocation of the logging was done a certain amount of times, but there's nothing asserting that the log message is the expected one. We can improve this by going to the dummy logger and sending the message in the closure when the login is called. So we can add a string to the closure and pass it when the login event method is called. And now we gotta fix our factory methods. And instead of having a log errors call count variable, we could have a variable called receive log messages, which instead of being an integer, it's going to be an array of strings. Initialize it to an empty array, and in our closure, when the login event is called, we're going to append the new message. And in our assertion, we're going to compare the received messages with the messages we are expecting to receive, which is only one message. So instead of injecting an integer, we're going to inject the expected messages, which is going to be an array of strings, and we're going to compare it in the assertion. Now it's time to fix our tests. We're going to inject an array with one message, which is going to be of type ISSTracker loader error.connectivity.localized description. And in the successful position loading test, we're going to expect an empty array of messages. So we can run our tests again. And they're passing. So now we're not only testing the amount of times that the logging event was invoked, but we're also testing that the log message is the correct one. It's time to commit, improving dummy logger to be able to assert log messages. Now it's time to move our code to production. Run the tests again to check that everything is okay. And it is. Move EventsLoggerDecorator ISSTracker position loader extension production. Cool. And the last part is going to be the composition. So we're going to go back to our app composer. We're going to instantiate the EventsLoggerDecorator. We're going to inject the same login instance, and the decoratee is going to be the remote ISSTracker loader. Now we replace the remote ISSTracker loader for the ISS position loader logger decorator. And there we have it. In order to test it, I'm going to turn off the network connection and I'm going to run the application. And there we have our error being logged. But as you can see, the log message is not very descriptive. So we can go and improve that. We're going to go and access our connectivity error. And the trick is going to be to extend it and implement the localized error abstraction, which has a property called error description, which we can implement and customize our login message to a connectivity error has occurred. And we gotta make it public. Now if we run application again, right there we can see our log in the console displaying the localized error we just implemented. And we also get the customized message in the alert of our application as well. So that's it for this video. I hope you enjoyed it. If you liked it, give it a thumbs up and subscribe, and see you in the next one.